Today's lesson is about how to complete fill-in-the-blank proofs. So let's go ahead and get started on just putting reasons in the correct order. So for this first section, what we're going to do is the statements are all in the correct order, whereas the reasons are all jumbled. So let's go ahead and just kind of think through our problem. The first part of our proof is always given. So it says given B is the midpoint of AC, prove AB plus CD equals BD. Step 1 should always be your given, and it doesn't have to be, but whenever we're completing a proof, you want to copy it word for word as step 1. So step 1 says B is the midpoint of AC. That's definitely not substitution, it's not definition of midpoint, segment addition postulate, or definition of congruency. We know that this information is given because it's clearly listed as the given. So this first step is given. Then we're kind of looking here, AB is congruent to BC. So segment AB is congruent to BC. We would know that this is true because in our problem we have a vocabulary word, midpoint. B is the midpoint of AC. Well, if B is in the middle of AC, that would mean that AB and BC are equal. So step 2 is actually a definition of midpoint. Remember, in definition of midpoint, they are congruent first. So the second step is definition of midpoint. The change from step 2 to step 3 is that the congruent sign is now an equal sign. Whenever that happens, that is called the definition of congruency. The definition of congruency changes equal things to congruent or congruent things to equal. So step 3 is the definition of congruency. Anytime you're going from congruent to equal or equal to congruent, that is definition of congruency. Looking at step 4, we kind of notice that we're adding some segments together. So let's look at our picture to kind of help us. It says segment BC plus CD equals BD. Well, I'm adding two segments together to equal the big segment. That is segment addition postulate, or SAP. So step 4 is SAP, segment addition postulate. Comparing step 4 to step 5, we notice that BC has been removed and it's been replaced with AB. That's just called substitution. The segment BC is removed and we just sub in an equal segment. So the final step in our proof is substitution property of equality. So the correct order for our reasons are 5, 2, 4, 3, 1. Also, we know the final step has to be proved. They have to match, so just make sure to always check. That tip is going to come in useful right here when we do a fill-in-the-blank proof. So we've got given angle 1 and angle 2 form a linear pair, and angle 1 plus angle 3 equals 180. Prove angle 2 is congruent to angle 3. So there's a lot of jumbled stuff up in here. The first step is blank. This should help us remember that given is always first, and we want to write it exactly how we see it. So I'm not going to change anything. I'm going to write angle 1 and angle 2 form a linear pair, and I'm just abbreviating. You're allowed to abbreviate. And then angle 1 plus angle 3 equals 180. The reason I have to support that information is the fact that it's given. Given information. Let's continue on through our proof. So continuing through our proof, our next part says angle 1 plus angle 2 equals 180. If I use my picture to kind of help me understand what the equation says, 1 and 2 are side by side and they form a line. That's a linear pair. Also, we have the vocabulary word linear pair in our problem. So step 2 is the definition of linear pair. Because what we have is we have two angles adding up to equal 180. In this next step, it looks like we have angle 1 plus angle 3 now set equal to angle 1 plus angle 2. This is called the transitive property. We have two things equaling the same, like A equals B and B equals C. A equals C. So what we can do is cross out what's the same and set what's left equal to each other. So this step here, when we set these two pieces equal, this is called the transitive property of equality. To get from step 3 to step 4, what happens here is it looks like our angle 1's disappear. And we know mathematically we can't just put disappear as our reason. If we move angle 1 to the other side using subtraction, the angle 1's will cancel, leaving us with angle 3 equal to angle 2. So this reason is the subtraction property of equality. Our next thing wants us to use symmetric property of equality, and symmetric is where you flip-flop. So angle 2 equals angle 3. Because remember, our goal here is to have angle 2 first, and in this problem, angle 3 was first. So symmetric property flips it. If I have no idea how to finish my problem, I know my last step should be what I'm trying to prove. The whole point of the proof is to complete the goal of proving angle 2 is congruent to angle 3. So even if I'm completely stuck on a problem like this, I'm still going to know what my last step is. It doesn't change. In this case, just like the one up above, we went from congruent and changed to an equal sign. That's the definition of congruency. In our final proof, we have blank 1. It says angle 1 is congruent to angle 4. Prove angle 2 is congruent to angle 3. Okay. So filling in our proof, we should all know now that step 1 is always given, and the reason is always given. Angle 1 is congruent to angle 4. Reason is given. Next, our reason is the definition of congruency. What we want to use here, we should know definition of congruency, just like up above, changes equal things to congruent or congruent to equal. So if I need to use definition of congruency next, I'm going to go ahead and make these equal each other. Our next step says angle 1 plus angle 2 equals 180. Now notice there's no vocabulary in this problem. That means we actually need to look at the picture. Angle 1 plus angle 2, if they add up to 180, that is a linear pair. They form a straight line. So that's the definition of linear pair. And I'm going to abbreviate linear pair just with LP. Also, we could use this as kind of a trick to help us figure out what's going on if I'm stuck. Next, notice just like above, we have angle 1 plus angle 2 equaling to 180, and we have angle 3 plus angle 4 equaling to 180. They both equal the same, so we can get rid of what duplicates and now set these two pieces equal to each other. That is called the transitive property of equality. Looking in this step right here, our goal is to figure out what happened. Notice here how we have angle 4s on both sides. If angle 4 is on both sides of your equation and then the next step it disappears, that means it's been removed using a property. So if we subtract angle 4 from both sides, the angle 4s cancel, leaving us with just angle 2 equal to angle 3. So that is subtraction property of equality.